Thank you everyone for being here. Today I will talk about Angular and AI-driven UX with AI-assisted interactions. This is our agenda for today. I will start with an introduction, a small disclaimer of what we can expect and not expect, small look into the architecture of the small project. Then I will give you a demo. The demo will go into more detail on what is happening and also in the code structure. We have some takeaways in the end, some advice, and if you have some questions left, we will deal with them at the end. So to me, I'm Mario. I'm a front-end developer at Color Intelligence. As said before, our booth is currently there with my colleagues. I'm 37 years old. I think around 10 plus years in front-end development. And yeah, as you said before, I like to dabble into other things. And currently today, in our time, AI is more present. So we will talk about AI. So in our talk today, my disclaimer, what to expect. We will have an introduction using LLMs to support modern user interactions. So we will see some formulas, for example. Normally you will write down in the fields and then in the fields will get sent to the backend. We will try something different today. And we will have a use case, a relatable story to show how we can accomplish this. And we will do this by some common structures from Angular itself. Reactive forms, unfortunately, I would like to try it with signal forms, but reactive forms is more stable for me to show for you. And in the demonstration, we will have a technical deep dive. And yeah, we will see the takeaways later on. What not to expect. It's not about chatbots. Some of you might work in projects where you're trying things out with AI, and most of the time it's about chatbots, AIs that get the context from internal projects, and then people going on your webpage will ask the chatbots. It's not about this. It's about something else. This is not about AI as development assistants. We have plenty of talks today already, very good talks about how we as developers can use AI for our development process, like Copilot. This one is more about using AI as a product. How can we use it in a product sense? And people using our formula will be assisted by this AI. This is not a complete, fully fledged software solutions, so please don't expect this to be perfect at all. This is more like a laboratory, and I'm trying to give ideas on how we can use them to leverage filling out forms, for example. Also, this is not agentic AI. So our story for today is more or less like patient profiling. Imagine you're working in a hospital and your task is to profile new patients on first sight who come into the ER room, and then you have to stand there, look at them, and you have to fill out some stuff by hand with paper. The more digital approach right now is to use a software for this, but it's also a very stressful time to do so. So you have to be fast, you have to be efficient, you have to look if there's something happening, and we have time constraints, so we want also to try to reduce time we need to do this. So we are in need for a fast profiling solution, which is operable with minimal hand input. Now I will show you the architecture of our current demo in the broad side. So imagine we have an actor who is putting in some input. We have a front-end, classical front-end backend structure. The data gets sent to the backend. And the backend then sends the context with the data, with the prompt to our LLMs. We have two LLMs in this case. These are also local. So as you might see, medical data is very sensible. We don't want to use it on the internet, so we are running them locally. We have two of those. One is a multimodal LLM, because we will work with pictures. It sends visual description to our text and structure LLM. This one can also receive it via the backend. And then once this is done, we have a structured result. The structured result gets then passed in the backend back to the front end, and the result can be seen by the actor. So in a more in-depth way, how we will do this in this demo, we have Angular. We have a profiler component with reactive forms. We will use certain services to do backend calls. And as you can see here, we will use a base 64 coded image or a voice text transcript. And I'm really hoping when I'm trying this demo with a microphone, the voice will work. In the backend, we have an API. This has a middleware, which is called Malta. We'll take the base 64 image and will provide a local upload. And if we use a voice text transcript, for example, both of them will then be passed in prompts and context. As you can see in the bottom of this architecture, you will see that we have form data, and the Angular frontend, also the Express backend, knows about this form data. This is important because we have a certain challenge to accomplish with our LLMs. We want them to be scalable. Our LLM should always have the current context in our project, because we want to see what happens if we have new forms, if we apply new form fields, for example. So we want to profile our patient. We see, we have to do some more fields to fill out. For example, do we have some wounds we can see? Then our user has to write down if there are any wounds. Or maybe if he wears glasses, is he bedridden? Can he walk, for example? We have a certain LLM client within our backend that communicates to our local LLMs. And in this demo, we will use Ollama. Ollama is a nice program that you can run locally with a CLI and host certain LLM models. In this case, like I said before, we have two. We will use Gamma 3 with 12b locally to parse image and context. And then we'll give visual description to our Mistral latest structured LLM. This gets passed back as a JSON object. We want to maintain this as always give back JSON. And then once this is done, the parsed JSON objects get back to the API, consumed by our services, back to our reactive forms, and then we will see the results in the front end. Now to our live demo. So I have this little project right here, as you can see. This is our medical profiling. We now have certain fields: the first name, last name, estimated age, eye color, hair color, and notes. And I will start by recording voice right now and see what our LLMs can do. So our patient's first name is Jack. His last name is Sparrow. His estimated age is around 50 years old. He has brown hair. He has blue eyes. And he seems to like to be a pirate. So now it gets back to the backend, processed, comes back today. Again, you see at least, so you can see some of these things right now need some of corrections. So we will just do this. And then we have more of our stuff written down already. Because we don't have eye color right now, we will do it again. His eye color is blue. So we try our, there it is. Now we will see that we also can correct stuff after we have already done so. And in the next demo, I will try the camera. Let's see what happens. This takes a bit longer, so I will try to show you what happens in the console. You will see that in this case, in the first one, we have the Mistral response, which gives back the JSON. As you can see, it says Jake Sparrow, estimated age correctly, hair color brown, nose pirate. Now we will see what our Gamma visual model said. Description of a person, the image. Appears to be a man, likely in the 40 to 64 age range. Not that far off, not that far off. Not exactly feeling flattered right now, but yeah. Hair color is brown, graying is visible. Also, yeah, especially at the temples. At least it's honest. Eyes are brown, does not to be, so I'm not wearing glasses, which is very good. Facial expression, and then we will see this one gets passed into our other LLM and puts out the JSON structured object. And we will see everything has been filled out with this nice image of myself right now. We have some more notes. Which is very fair because we told our LLM to be critical and it shouldn't assume things, so it shouldn't hallucinate. And I will show you what the current infrastructure is all about. So we have our form in the front end. Let me do it this way. It's a very generic template where you just pass certain form data in reactive form. You can apply new data later on. The form data looks like this. There's 2 experiments I tried out. I tried using text fields, especially for age or for height or weight. But the problem is we want to have a more deterministic approach, or at least a range, because giving the exact age of someone by the AI is a bit of a problem. So maybe the age range could be a better approach. So on the second one, I tried selects, and I will show you later what happens if we apply certain new fields. These are then passed to a function that takes this object pattern and puts it to JSON schema. Some of you might know JSON schema is an agnostic approach to build a structured JSON file and can be used by certain languages and so on and so on. This also applies in this case to Ollama LLMs running locally, because if we look at the backend, we can see our AI routes. We have analyzed text and analyzed image. I'm starting with analyzed text. We will send the text and the form structure, or take it from the body in this case. There's nothing there. We've put out an error. We will create our prompt. This is the text prompt right now. The text prompt is structured like this. We will start for our structured AI via context to tell him what he has to do. So he's a reasoning model, converts descriptive or visual text into structured form data. So now it knows its role, and he should use valid JSON object as an output. As you can see here, it is structured as Markdown. So we have the form structure, and we give it context by a parameter in this function. So the form structure gets passed as a string, and also the user input gets passed as a string. That could either be the voice transcript or the visual data provided by our Gamma AI. And then we have certain extraction rules, because some of you who already worked with LLMs and prompting will know that if you try something to be more deterministic, you have to put in more rules. You have to say, always do that, don't do this, and so on and so on. And in this file, we have the property coverage. It should look at our properties. It should say how to use them. Data typing. In our case, we have number, text area, and select, and how he should use these. So if he sees a number in our form structure, then he should use an integer or float. For text, it's just descriptive strings, and select is a bit of a special one, as you can see in the third select field logic. You should look at the available option values, ignore the labels, choose the single most semantically appropriate value. If it doesn't fit, return null. When doing this, I did not use this one. This one is a more detailed approach on how to do so, because if I don't use this, for some reason Mistral with the context fields starts hallucinating. And when you give an LLM a structured approach on how to pass the data you give it, it gets more deterministic. It's still not 100%, but it gets to, like, feeling-wise, 80%. And because sometimes we don't have data about the name, what happened when I gave them the image, for example, it tried to hallucinate names for me. Many names I didn't want to have. Some were cool. But in this case, I don't want to have it. And in the end, the output format, give it a JSON object. Don't give any explanation, no reasoning, no markdown formatting, should just be JSON. And if you really want to push it, one thing that is really nice is give it examples on what to do and what not to do. So in our case, we have this structure, for example, for our select box. For the eye color, it's blue, brown, green, or other. Then here's the text. What is correct is brown, but it shouldn't just pass back dark brown. We need this because we have a certain structure in our Angular application for our forms, and we want to make sure that the keys are always the right ones. And when you have select boxes, it should take the right value from it. The image one is a bit more interesting because it's less to write. It's just about giving the context first. It should be a task is to have an image that is base64 encoded and should analyze it. It gives the context and what field it is. It's a medical field. Again, we give it a form structure, and it should then derive every possible property from the form structure and give a comment on this as a descriptive field. This one is not as strict as the other, and I will explain later why. When we do this, in the end, we will call the LLM. We have a function that is our client. It takes the model name, because we have two, we need to address the right one in the right situation. It takes the prompt, and it also takes the format. And most of the time, if we do this, then when we put the right format for example, you will have the JSON schema format and then put it in the LLM. Then it knows, okay, now I can output the right JSON structure. In some cases, we don't want this. But in our structured case, this is exactly what we want. This is why we have the text call for Mistral is always prompt and form structure. And the difference in the image call is we just give it the analyze image prompt without our form structure, which is left empty. If it's empty, it just does stuff for itself. If you give it the form structure, then the exact JSON will be put out. We have certain parameters, and I will talk about this in a minute. Let's see if we can see the current status. We will reset the form, and then we will add some more fields to our form. So now we reloaded it. I will take another nice image. And we will see if I have some wounds I don't know about yet, or if my mobility is still standing, and my clothing type. In the meantime, we can look at the output again. This was the last one. The problem with our current implementation is this model takes a bit longer to process because it's running locally, I think with more power in that regard, like online cloud services, for example, it would be better. But in our case, we want to show how it deals with it locally, because in some cases you want to have sensible data stay locally. So, again, I'm 40 years old, at least. My eye color is brown, hair color is brown, no wounds, no glasses, I'm walking. And the clothing type, dark, possibly navy blue collared shirt. It's okay. We can deal with this. So now some takeaways about this approach. When doing this demo project, I tried different models to test it out. When you're using Ollama, you can use it locally, and then you can pull certain models from it from a database. There's an online API and online documentation of it, which models are available. They are especially some of the visual ones for multimodal, they're text ones. And when working with it, there are different outcomes. After some time and tinkering around, these one, I think, are a good starter. But even then, prompting and parameters are still very important. I think prompting is something that will always be very important, and we have to take care of this because we want to increase deterministic results. And what I wanted to do is try to provide an idea to give dynamic context. So what we want to do is we want to have an AI that parses data, but what happens if our data structure changes? And we want to give the idea of using normal LLMs without any agents, or for example, and take the form data for example, and put it into our backend to the LLM, which then increases the context and gives the right idea to the right time. So the models I've tested was Lava 13b. The problem for, I don't know why, but it keeps ignoring prompt structure. It was really a problem because every time I put an image into it, sometimes it would put out the fields we want, sometimes it won't, but it was not deterministic. Even after setting the parameters I come to later, and it was relatively weak for detecting certain things in the image. Especially if you give it a medical context, it will tell you about something else in the picture, for example, the plant in the background or something, which is not what we want to do. Baklava is another model I've tested. It's still Lava, but it has some more structured approach in the how do I say it? under the hood. Same as Lava, but the problems were the same. When I tried Gamma 3 with 12b, I had the best outcome because it's still not perfect, but one of the things I can say, it gives one of the best detection based on the image you give it, especially if you scope the context for it. And the prompt structure you give it, the model is very deterministic in getting this prompt structure and not ignoring your prompts. The params and prompts should be followed by best practices. We have seen some talks already where we even have a generator who checks out your prompts and says if it's good and useful. The concept in this one is if you are using a multimodal vision LLM in this, like you want to do it in this demo, you can be very descriptive and not structured because you want to have this LLM talk to the other one like it sees something, like a person. The other one, if you're prompting there, it should be structured with clear instructions, so you have your deterministic value. The context can be given via the description of the task. So in the first lines, you are someone you have to analyze a voice transcript, or you are someone who gets an image and you are in a medical field, analyze this image as someone who is in a medical field. This helps the LLM to process the right information. And when using Ollama, you can use certain useful parameters. There's temperature and top P. Temperature and top P are the ones that control how random or creative the LLM can be. If you put the value relatively low or 0, for example, your output, when you don't change the prompt, will almost be the same. It will use some different words, but if you structure the words how it should be outputted, it stays almost the same. Not perfect. NumCTX is the context that is based on the LLM. Why is it useful? Because you can control how many tokens you are giving in, and the less tokens you are limiting, the best you are limiting the context, the faster it processes things. So you can try to reduce the context of multimodal vision LLMs, for example, and what happens is it gets a bit faster. And numPredict is the output. That's the tokens the LLM is using for the output. Also, if you are trying to reduce it to a certain point because of JSON structure, for example, you can say, my JSON won't be 1,000 lines long. So I can reduce it, then our structured LLM also runs faster. And in our demonstration, we have set it, for Gamma it was like 16,000 and NumPrediction is 1,024. That's a value to give a descriptive text, but it shouldn't be too long. And for our text one, it's a bit shorter. So that's also faster. The top P value in this case is helping to identify if you're trying to have a fallback, for example. In our case, the fallback is we don't trust the LLM fully. We still have a user interface to let the person fill out the form manually or correct it. And if you're setting top P, for example, a bit higher, it gets more creative in some ways. You can implement a way to validate the data you're getting from the LLM, and if it's not sufficient, you can just retry it. And if you're doing this way, it's a nice compromise to be still deterministic, but have some kind of slow variation in it. To the dynamic context, our main goal was to be scalable in LLM detections and structure, because we want to have context that is based on our form structure model, which can be accomplished by sending the form structure as agnostic model to the LLM. And because it's JSON schema, it can also be used in other contexts as well. So you can add something more to this architecture and use it in this case. As you can see, the prompt is injected with JSON schema 7 as a string in the prompt itself. And also, we want to have it as a parameter for Mistral to output it as JSON in this schema. The structured output, as you can see here, is with a format parameter. If you change the form, the AI always knows about new fields or less fields, so the output generated will always be on par with what is current. And as a future idea that can be used is, imagine you have our current form data. And we could add something like this. This way, we could try to get more task details for each field and then adjust our prompt accordingly. So now you can even say what the current AI should pass out. So, thank you all for being here. This was my talk. And if you have any questions, I'm here for you.